So welcome back students to my course, and let's start our tutorial 8 slope aspect and DEM. At first you should open the ArcMap document tutorial 8 slope aspect and DEM, and at the same time open the Word file tutorial 8 calculating slope and aspect, and calculating actually DEM slope and aspect. So let's start our module practical exercise. Creating DEM from point observations. So at first open tutorial 8. On the table of contents you can see point vector dataset elevation points containing information about the observed elevation points. How many points are stored in the dataset? So at first here is our table of contents, and we can see that the interpolation data frame contains two datasets, region and elevation points. So at first let's open elevation points and see how many point observations and how many point features it has. So here we can see that it's 100. We can use snipping tool and show that it contains 100 point features. What is the average height of the observed points in the region? So here is our attribute height, and we should find the average height observed in the region during the field work. So go to the statistics, open, and here we find the mean value is 777. So the average elevation from the 100 observed points is 772 meters. So open and now we should create the digital elevation model from this point observations. So here we have as an input we have vector dataset, right? And as an output we should have the raster dataset, because digital elevation model is always raster. So how we can create raster dataset? Using the interpolation method. On the table below you can see that we should use three types of interpolation methods. Actually there are two types, but three different variables. At first let's start with the IDW, so open spatial analysis tools, interpolation, IDW. So spatial analysis tools, interpolation, and IDW here, and set the cell value to 30 meters and power to 3. So at first let's start elevation points, and we should always mention here z value field height, and cell values, output cell size is 30 meters of pixel, and power to 2. Okay, so power is 2. Set the output extent max to region shape. So let's go to the environment, and output extent mask is region, right? Let's click OK, and that's it. Okay, so now it's creating the digital elevation raster, model raster, from these input point observations. Let's close this one. So here is our digital elevation model. Actually I made a mistake here, because I should choose the mask also, the extent also as well, besides the mask. So height again, output cell size is 30, power is 2, environment. So don't forget to put also extent, same as layer file, and mask. mask as region. So extent is not the same as layer region. So okay, now we can create put OK and see the result. So it's creating output raster dataset from this point observation, which will serve as a digital elevation model for us. So it created interpolation from the input rasters, input point, right? So it just interpolated, created a model of the surface of this region according to these elevation points. So it's not just a 100% approximation of the surface. It depends on the various factors how your digital elevation model is close to reality. At first, you should have more samples, right? More samples within a small region. We have here only 100 samples for the relatively big, large region. Also, it depends on the cell size, because I could create a 1 meter pixel resolution. Also, it depends on the interpolation method you choose, the various factors, indicators you put, etc. So let's first write here interpolation power 2, right, in order to remember. So here is our output data set, which we gain. We could also change the color of our continuous raster, because it's always digital elevation model is always a continuous raster. You can see from these values, and also you can check the pixel values, which are float values. And here we don't have also attribute table because it's a continuous raster dataset, doesn't have a attribute table. So anyway, we can change the color ramp, right, to make it more close to, okay, we can go to stretched, and color ramp is this one. So now it looks more like a ordinary raster dataset. So here we can see that the values differ across the points. We can see the white colors represent high elevation, and the dark colors represent low elevation. So it's just a random sample. So your output raster dataset will look different because if you measure them accurately and precisely. So let's go to the fourth question. Repeat the same steps with the fill using the table below. So why here is 300, actually should be 30 meters. So we should repeat the same steps and apply the various interpolation methods. So again, here is one should be 1 IDW 25, right? So okay, let's at first measure the minimum and maximum for this raster. Minimum is this 141. We should just remove this. Maximum is 146, 1000, and average value is mean 768. So you can notice that actually it differs from the statistics tool we measured during in the attribute table. So let's again repeat the same steps but apply another value. So again we choose elevation points, height 30 meters, and the power now should be 4, and the number of neighboring points should be also 4. number of points should be 4. Power, weight, cell size. Okay, type is variable. So again, let's don't forget to apply mask and an extent, okay, because it directly will influence your output results. So okay, region, now it's calculating. Actually, the calculation can be faster if you will choose a pixel or another pixel resolution, lower pixel resolution. So again, it's IDW4, right, with 4 neighboring points. I think it was here 12 neighboring points, power 2, and neighboring points is 12. Okay, again, we should measure the statistics from this raster. So 141, the same result. The maximum result is 1497. So a little bit different, but actually the same. So average is 774. 774, so a little bit different from this. So again, the IDW height 30, power is that's 50, okay, 50, and number of neighboring points is let's take 12, okay, so 12, and the processing extent same as region, and raster analysis mask is same as region. So let's click OK. Now it's calculating. So we used IDW power 15 and the number of neighboring points 12. Let's see which results we will obtain. So let's first, I will change the power 50 and numbering points is 12. So see, the results actually really differ from our other values. So you can just see from the image itself, it's actually really differs because we changed the input numbers. So the out maximum and minimum the same, the average also close to the previous values, previous interpolation methods, but the output result we can compare, see, very differs from our. Can also change the color ramp, right, from the symbology stretched. Such kind of result. So you will understand, you should know the difference between the same interpolation method when we choose another input indicator for power, and for this search radius can power this one, that the exponent of distance controls the significance of surrounding points on the interpolated value. A higher power results in less influence from distant points. So the distant points have a small influence to each other. It can be any real number greater than and the number of points defines which of the, okay, you can just repeat the lecture. And the last one is spline method. Let's apply it. So again, height 30 meters, and we should choose weight 4, number of 0.5, and regularized spline, right? So the type of spline yields a smooth surface and smooth first derivatives. So okay, let's click OK and see the results. We can observe from these values they differ very slightly. There is no huge difference between the minimum, maximum, average values, while the image, the output map from IDW, when we applied power 15 and the numbering points 12, see here is actually 12, the output image is very sorry, I just forgot to apply extend and mask. 13 regularized, weight points, environment, processing extent, region, and processing mask, analysis, and mask, again region, mask, extent. Okay. So here is our spline, and we can see, can now fix the differences. Can also make this stretched, and see the results, statistics. So minimum, see, it's actually very huge difference from this. From this one minus, we can delete this part. Maximum is this one, and mean is this. So here is the big differences between them. So when you apply IDW model, it only just takes the results from mostly from that input vector, input points, and do not go far from these values, minimum, maximum, and average. But when you apply spline model, it works a little differently. You can again watch the video and understand the concept of spline model. So when you change the interpolation method to create digital elevation model, or just any model, just not elevation model, you can create all the type of DTM. You should clearly understand the purpose of the model you're creating, and according to the purpose of the you want to achieve, you should choose the interpolation method and the input values for your interpolation method.